Right now, Google is spending absolutely billions of dollars on artificial intelligence infrastructure,
Oh, yeah. Massive amounts.
literally building these server farms the size of football fields. And they are packed with these proprietary, super expensive enterprise chips that suck up enough electricity to, power a small city.
Right. Whole municipalities of power.
Exactly. And OpenAI, I mean, they just raised billions more to do the exact same thing. We are constantly told, basically every day in the news, that the future of AI belongs exclusively to whoever can build the biggest, most unfathomably expensive computer.
That's the narrative. Yeah. Bigger is always better.
Right. But the biggest breakthrough in AI video generation this entire year didn't come from some massive glass building in Silicon Valley.
It did not.
It came from one guy sitting in a room with 7 graphics cards he literally just bought off a shelf.
Which is, frankly, a reality check for the entire industry.
Seriously.
Because we were looking at a fundamental dismantling of that exact narrative. The whole "you need $1 billion to compete" idea is just falling apart.
Well, welcome to today's deep dive. We are completely deconstructing the mechanics, the hardware, and the, honestly, jaw-dropping economics behind this new platform called ZSky AI.
It's a fascinating teardown.
It really is. We're breaking down a teardown of this tool, and the core premise we're exploring today revolves around this solo developer named Semhan Biricik.
Right?
And he has seemingly beaten these trillion-dollar tech titans to an industry milestone that people have been chasing for years.
Years, and with a fraction of the resources.
So if you are a digital creator making content, a tech enthusiast, or, I mean, honestly, just someone fascinated by how massive industries get disrupted literally overnight, you need to hear this. We're going to explore how the barrier to high-end cinematic creative production hasn't just been lowered. It has been completely shattered.
Shattered is the right word for it.
Okay, let's unpack this.
Yeah.
Because before we can even talk about the wild cinematic video this AI actually makes, we really have to look at the physical hardware running it.
Yeah, you have to start with the metal.
Because the setup defies every single conventional rule of tech startups.
It really forces you to rethink what constitutes a supercomputer in 2026.
Totally.
Because when we normally talk about AI infrastructure at that corporate level, we're talking about enterprise-grade hardware. We're talking about NVIDIA H100s or, the B200s.
The stuff that's always backward.
Exactly. These are chips specifically engineered for massive data centers. They cost tens of thousands of dollars a piece.
For one chip.
For one. And companies buy them in clusters of 10, 20, sometimes 50,000.
Which is just insane to think about.
And they require specialized cooling, specialized power grids, and literally an army of engineers just to maintain the wiring between them.
Right, like the stuff you and I literally cannot buy. I can't just put an H100 in my shopping cart on Amazon.
You absolutely cannot. They wouldn't even sell it to you. But ZSky AI is running on exactly 7 NVIDIA RTX 5090 GPUs.
7 total.
Just 7. And the crucial distinction here is that the RTX 5090 is a consumer graphics card. I mean, it is the absolute bleeding-edge, top-of-the-line consumer card, yes. But it is fundamentally designed for high-end PC gamers, or 3D artists, or freelance video editors.
So anyone can buy it.
Right. You can walk into a Best Buy or go online and just buy one. They run on standard wall outlets.
Wow.
And Semhan Biricik just took 7 of these consumer cards, strung them together, and is using them to power a public-facing AI video generation platform.
Let's talk about the actual capacity of those 7 cards, though, because the numbers coming out of this teardown are staggering. Those 7 GPUs working in parallel are providing 224 gigabytes of VRAM.
Which is a very specific, very important number.
Yeah, and on that setup, the system is operating with an average latency of under 3 seconds.
Under 3 seconds.
And it is kicking out fully rendered 1080p cinematic video clips in around 8 seconds.
It's just absurd. To understand why that latency is so shocking, we kind of need to break down what VRAM actually does during an AI generation task.
Yeah, let's get into that. What is the VRAM doing?
So VRAM, or Video Random Access Memory, is essentially the AI's workbench.
Okay.
It's the ultra-fast, short-term memory where the model holds all the data it needs to perform a specific task at that exact moment.
Like having everything laid out in front of you.
Exactly. When you type in a prompt to generate a video, the AI has to load the neural network weights, which is the actual brain of the AI, into that VRAM.
Right.
Then it has to create a noisy canvas and step-by-step refine that noise into high-definition pixels across dozens of individual frames of video.
So it basically has to hold the entire sequence in its head at the exact same time.
Precisely. If your workbench is too small, the AI just can't fit the whole problem on the desk.
So what happens then?
It has to constantly flop data back and forth from your slower system memory, and that grinds the generation time to an absolute halt.
Ah, gotcha.
So 224 gigabytes of VRAM is a massive desk for a home setup. It is an incredible amount of memory for one person to orchestrate in a garage.
Right, for a normal person, that's huge.
But compared to the petabytes of memory flowing through OpenAI's servers, it is microscopic. It's a fraction of a fraction.
Yeah, it's a drop in the bucket.
Yet the 5090s are so insanely fast at processing what is actually on their desk that they are clearing those generation tasks in 8 seconds.
I mean, the raw speed of consumer hardware has essentially crossed this invisible threshold.
It really has.
Because we used to look at tech startups and think, okay, you need a $5 million seed round just to rent the compute power necessary to even test a prototype.
Oh, absolutely. The
Yeah.
AWS bills were legendary.
Yeah, but now an individual with a vision and maybe a maxed out credit card can just assemble a cluster in their garage that rivals the output speed of heavily funded labs.
It completely democratizes the foundational layer of innovation. The gatekeepers of compute are just losing their grip.
Okay, I hear that, but I have a major technical hang up here.
Sure.
The math just doesn't add up for a public platform. Well, ZSky AI has a free tier. Anyone with a web browser can hit the site and start generating video. Let's say a big tech influencer tweets about this today, and suddenly 10,000 people flood the site in a single hour.
Which happens all the time.
Exactly. 7 consumer GPUs, no matter how fast they are, have physical limits. The workbench is only 224 gigabytes. If 1,000 people hit generate at the exact same millisecond, you cannot fit 1,000 complex video generation tasks on that one desk.
No, you can't.
It mathematically has to bottleneck, crash, or put people in a 3-day queue.
Your skepticism is completely warranted here. On a purely hardware level, handling internet-scale traffic on 7 GPUs is physically impossible.
Right. You can't cheat physics.
You cannot cheat the laws of thermodynamics or silicon bandwidth. If you try to run a traditional massive AI model on that hardware and expose it to the public, it will melt down instantly.
The queue would just stretch to infinity.
It would be unusable.
So they are cheating somehow.
They are entirely cheating the hardware limits.
Yeah.
But they're doing it through absolute architectural brilliance on the software side.
Okay, this is what I wanted to get into.
Because you can't just be clever with your wiring to survive on a lean setup like this. You have to fundamentally change how the AI thinks.
Right.
And this brings us to the software infrastructure running under the hood of ZSky.
The secret sauce. Because when you look at the breakdown of how ZSky is actually operating, it completely rejects the philosophy that Google and OpenAI are just obsessed with right now.
Total rejection.
ZSky does not rely on one single massive AI model. It utilizes a custom pipeline of over 12 different highly specialized AI models.
Which is a complete paradigm shift from the monolithic approach.
Explain that monolithic approach for a second, just to contrast it.
So the massive tech companies are locked in this arms race to build the ultimate monolith. A single, omnipotent neural network.
Right, the one model to rule them all.
Exactly. The goal of a monolithic model, like the architectures driving the biggest chatbots and video generators, is to have one giant brain that knows how to do absolutely everything.
Everything.
It understands physics, it knows how to paint in watercolor, it can render human faces, it understands fluid dynamics for water, and it can generate text, all in one place.
Which, I mean, sounds great on paper. You want an AI that can do anything you ask it.
It sounds amazing until you actually have to run it.
Right.
Because when a user asks a monolithic model to generate just a simple 5-second clip of a car driving down a road, the system still has to load that entire massive omnipotent brain into the VRAM.
Oh, wow. So even for a simple prompt.
Yes. It's dragging the knowledge of watercolor painting and human facial anatomy into memory just to render a car.
That seems...
It is incredibly inefficient. It requires industrial-sized hardware just to turn the machine on.
It's like building a house, right? The monolithic approach is like trying to hire one general contractor who is supposed to do everything.
That's a good way to look at it.
Like, he's kind of okay at priming, sort of knows electrical, can maybe do the roofing, but ZSky is doing something different. They are instantly hiring the world's best specialized plumber, the best electrician, and the best carpenter, depending on the exact blueprint you hand them.
Exactly. Or, to use a restaurant kitchen analogy,
Oh, I like that.
the monolithic approach is like trying to cook every single item on the menu, from a really delicate souffle to a massive brisket in one giant industrial-sized nuclear-powered oven.
Right.
Sure, the oven can eventually cook anything, but it takes an hour just to preheat, it costs a fortune to run, and if you just want to toast a bagel, it is a spectacular waste of energy.
Yeah, firing up a nuclear oven for a bagel is crazy.
That's highly accurate to what's happening. What ZSky has built is a kitchen equipped with a dozen hyper-specialized appliances.
Right.
An air fryer, a sous vide machine, a rapid toaster, a dedicated pizza oven.
So when an order comes in,
When an order comes in, it doesn't fire up the giant oven. It sends the ingredients to the exact machine built for that specific dish.
and the platform actually automates this through routing, which is wild. The teardown shows that when you type in a prompt, say, a retro rocket descending onto a Martian landscape, you aren't actually talking directly to the video generator.
No, you are not.
You are talking to a router.
And the router is the unsung hero of this entire system.
How does that work?
In machine learning, we call this a classifier model. It's a tiny, lightning-fast AI whose sole purpose in life is to read text and act as a traffic cop.
Okay.
It requires almost zero VRAM to run. So when you hit submit on your rocket prompt, the classifier model intercepts it, parses the language, and says, retro rocket and Martian landscape. I don't need the model trained on photorealistic human expressions.
Right.
I don't need the anime model. I need to route this request directly to model number 4, which is hyper-optimized for mechanical geometry and planetary environments.
So it only loads the specialist into the memory.
It only loads the specialist. And because model number 4 is so incredibly specialized, its file size is significantly smaller than a monolith.
So it fits on the disk.
It snaps into that 224 gigabyte VRAM workbench almost instantly. It doesn't carry the dead weight of knowing how to generate a puppy or a bowl of ramen.
It just knows rockets.
It just does rockets. It executes the generation flawlessly, clears off the desk, and makes room for the next user's request.
That is so smart.
That is the only way you achieve 3-second latency and an 8-second generation time on consumer hardware.
The efficiency is just brilliant, and the output quality proves it isn't cutting corners either. We are seeing incredibly high fidelity cinematic clips from this.
Oh, the quality is undeniable.
Like F1 racing footage where the motion blur on the tires looks perfect. Atmospheric cityscapes with ray-traced neon lighting reflecting off puddles.
Beautiful stuff.
The specialized models are objectively outperforming the generalist models in these specific categories.
Well, because specialization breeds depth. A model trained exclusively on architectural geometry and lighting will always render a better cityscape than a generalist model that spends half its training data looking at pictures of cats.
Yeah, that makes perfect sense.
Furthermore, this modular architecture gives Simhan Birichik a terrifying level of agility.
Because he isn't locked into one giant system.
Exactly. Think about it. If OpenAI wants to update their monolithic video generator to get better at rendering hands, which we know AI struggles with, they have to retrain the entire multi-billion parameter beast.
Which takes, what, months?
It takes months of compute time and millions of dollars.
Just to fix the hand.
Just for the hands. But if an open source researcher releases a brand new, highly efficient model specifically for rendering human hands tomorrow,
Yeah.
Birichik can simply plug that new model into his 12 pipeline system as model number 13, update the traffic cop to look for the word hands, and deploy it to the public by the afternoon.
That is wild. He's driving this modular speedboat while the tech giants are basically trying to parallel park an aircraft carrier.
The agility completely offsets his scale disadvantage.
And that speed of execution brings us to the absolute centerpiece of this platform, because having a fast, high-quality video generator is incredible. But it's not the thing that is breaking the internet right now.
No, it's not the main event.
There's a specific feature in this pipeline that the teardown highlights as the core differentiator.
It's the white whale of the generative video space.
Here's where it gets really interesting. ZSky AI has built in fully integrated AI audio generation directly inside the video pipeline.
Yes.
We are talking about lip sync, text-to-speech voice generation, and music generation.
All of it.
But the critical part, the detail that changes the entire landscape of this industry, is that it is perfectly synchronized.
Synchronized in a single prompt. That cannot be overstated.
To really grasp how massive this is, we have to look at the current state of the art from the multi-billion-dollar companies.
Let's do it.
If you look at Sora from OpenAI or Pika or Runway's Gen 3, these are the absolute titans of the industry right now.
The heavyweights.
Every single one of them only outputs silent video.
We are essentially living in the silent film era of AI video.
That's a perfect way to put it.
You prompt Gen 3 for a cinematic shot of a woman speaking in a cafe, and you get a breathtaking, photorealistic visual. It looks amazing, but it's dead quiet.
Right.
The lips might be moving randomly, but there's no sound whatsoever.
And if you are a creator trying to actually use that clip for a commercial or a short film, the workflow right now is an absolute nightmare.
Oh, it's brutal.
You have to generate the silent video. Then you export the MP4 file to your hard drive.
Right.
Then you go to a completely different platform like 11 Labs to generate an AI voiceover.
Another subscription.
Yep. Then you go to a third platform like Suno or Udio to generate some background music.
And then the fun part.
Then you open Premiere Pro or Final Cut, import all three assets, and spend an hour meticulously slicing the audio, trying to warp the speed of the voice track so that the syllables sort of match the random lip flaps of the silent video.
It's a highly fragmented, deeply frustrating workflow, and it completely shatters the illusion of instant AI creation.
It's not instant at all.
Not even close. What ZSky has done by orchestrating this all-in-one interface is shift generative AI from being a neat novelty like a party trick, where you generate a cool silent GIF into an actual functional creative studio.
Yeah.
You type a prompt, you type the dialogue, you hit generate.
And then
8 seconds later, you get a 1080p video with the music baked in, the voice generated, and the lips perfectly matching the phonemes of the audio track.
it's temporal consistency,
Yeah.
right? That's the technical hurdle everyone else is tripping over.
Yes, temporal consistency is the hardest problem in video generation by a mile.
Why is it so hard?
Because it is one thing to generate a static, beautiful image of a face. That's a single frame. It is exponentially harder to generate 30 frames a second, where the lighting, the skin texture, and the geometry of the face remain consistent as the head turns.
Right, so it doesn't flicker or melt.
Exactly. But when you introduce synchronized lip sync, the computational difficulty goes off the charts.
Because it has to match the audio.
The AI isn't just maintaining the face anymore. It has to analyze the text-to-speech audio file, break it down into microsounds called phonemes, so the B, the D, the O sounds,
Right.
and mathematically deform the pixels of the mouth in the video frame by frame to perfectly match those specific sounds at the exact millisecond they occur in the audio track.
And doing all of that, routing the text to the voice model, routing the prompt to the video model, generating both, and then running a third model to deform the lips and stitch them all together. All in under 8 seconds on a consumer GPU cluster.
It feels like magic.
It feels physically impossible, but there's a fascinating detail in the teardown that caught my eye. The pricing structure.
Oh, the 15 credits.
Yes, specifically, the lip sync feature costs exactly 15 credits per generation.
That is a very telling metric.
Why?
The 15 credit cost isn't just a random monetization strategy. It is raw, transparent proof of the compute weight happening under the hood.
Okay, so it proves it's real, not just a marketing trick.
Exactly. If we connect this to the bigger picture, we've seen polished marketing videos from major corporations showing off AI video with perfect audio sync.
Oh yeah, they post them on Twitter all the time.
Right, they publicly dare to show these demos, but they haven't actually shipped it. Those are heavily curated, pre-rendered demos.
Fanfic.
They are velvet rope presentations. You can't log in and use them yourself. When ZSky slaps a 15 credit price tag on the lip sync feature, they are acknowledging that the temporal consistency math, the phone matching we just talked about, takes up massive amounts of space on that 224 gigabyte VRAM disk.
So it's a heavy lift.
It forces the 5090s to work incredibly hard. By charging a specific credit premium, they are giving the user agency to trigger that heavy compute process, proving that it is a live, functioning, user-driven system.
But this brings up a massive friction point for me.
What's that?
I look at this reality. One developer, sitting in a room, figured out how to orchestrate a modular pipeline that handles video, text-to-speech, and lip sync simultaneously. Yeah.
Meanwhile, Google, with tens of thousands of the smartest engineers on the planet, and basically unlimited compute power, is publicly struggling to ship a synchronized video product to the public.
It's a stark contrast.
Are the giants just incompetent? Or is
Wow.
there a structural blind spot they're completely ignoring?
It's definitely a structural blind spot. And it goes right back to the architecture we discussed earlier.
A monolith.
The massive companies are burdened by their own scale because they are chasing that monolithic model, trying to force one giant neural network to do the video, the audio, and the syncing all at once inside a single brain. The complexity is literally choking them.
It's just too much for one model.
Every time they try to tweak the lip sync, it might accidentally degrade the quality of the video rendering because everything is tangled together in the exact same neural web.
So the giant oven burns the souffle while trying to toast the bagel? Precisely. ZSky bypasses this entirely with its modular pipeline. It generates the video with one specialist, generates the audio with another, and uses a dedicated sync model to marry them together at the end. It's an assembly line, not a monolith.
And there is also the corporate reality of shipping consumer tech, right?
Oh, massive factor.
A solo developer moves at the speed of code. He builds the feature, tests it on his 5090s, sees that it works, and just pushes it live to the web.
The lack of institutional friction is a massive advantage.
Like he doesn't have a legal team.
Exactly. When a publicly traded company tries to release a tool that can perfectly clone a human voice and sync it to a photorealistic human face, they hit a solid wall of internal bureaucracy.
Red tape everywhere.
Product managers, legal teams, and safety review boards spend 6 months just debating the brand risk.
Right.
A solo developer operating on the bleeding edge simply builds the cool and lets the market decide its value.
And the way this tool is hitting the market is incredibly aggressive. When we look at the actual economics detailed in the teardown, the distribution of this power is going to upend the industry.
The unit economics are fascinating, truly aggressive in the best way.
Let's run through the numbers really quick.
Go for it.
ZSky offers a completely free tier. You get 25 credits immediately upon sign-up, yielding basic image generation and 720p watermarked video.
Which is great for testing.
And critically, there is no credit card required to start.
Frictionless.
Then you step up to the starter plan, which is $7 a month. $7.
That's nothing.
For the price of a fancy coffee, you get 500 credits, full 1080p resolution, and no watermarks.
Amazing.
Finally, the Pro plan is $19 a month, giving you access to a priority server queue that generates twice as fast, allowing you to create videos up to 10 seconds long with advanced camera panning controls.
Offering a frictionless free tier, meaning no credit card wall to keep the casual users out while running your infrastructure on self-funded RTX 5090s, is an incredibly aggressive user acquisition strategy.
It seems risky.
Well, compute time is the most expensive commodity in tech right now. Electricity costs money. Hardware depreciates. Every time a free user hits generate, it costs the platform real pennies.
So is this sustainable? Or is this just a loss leader strategy to pump user numbers and attract a massive venture capital buyout?
It's a valid question.
Because we've seen this movie before, right? With tech startups subsidizing the cost of the product until they capture the market and then hiking the price, like Uber or Netflix.
It's a very valid concern, but the modular architecture actually changes the math here.
How so?
Because the classifier model is routing requests to those tiny, highly efficient specialist models, the energy and time required to execute a prompt on ZSky is a fraction of what it cost a monolithic competitor.
So his baseline costs are just way lower.
He isn't subsidizing massive compute losses at all. He has engineered a pipeline so efficient that giving away 25 free credits is just a negligible marketing expense.
Just to get people in the door.
You let the user experience the magic of synchronized audio with zero friction, and the sheer quality of the output naturally converts a high percentage of them to that $7 tier.
And when you look at the competition, $7 a month is devastating.
It really is.
The teardown points out that Runway's Gen 3, which is backed by tens of millions in venture capital, charges significantly more just for their baseline subscription, and it still lacks the synchronized audio capabilities.
It completely destabilizes the premium pricing models of the major labs.
Totally.
If you are a VC firm that just valued an AI video startup at $1 billion based on the assumption they could charge users $30 a month, this is a nightmare scenario.
Your whole business model is blown up.
A solo developer is offering a superior workflow for a fraction of the cost.
So what does this all mean for the actual creative economy?
That is the big question.
Because we are looking at a cascading effect across multiple industries here. Imagine you are an indie filmmaker, a YouTuber, or a creative director at a mid-size ad agency.
Right.
If you can jump into a web browser, type a prompt, and get a cinematic 1080p video with perfect lighting, a generated voiceover, and synchronized lip movements for $7 a month, The traditional supply chains of content creation just evaporate.
The stock footage industry is staring down an existential crisis right now.
Walk me through that.
Well, the traditional model involves flying a drone over a city at sunset, color grading the footage, uploading it to a marketplace like Getty or Shutterstock, and charging an agency $200 to license a generic 5-second clip.
Right. And you just hope it fits their vibe.
Exactly. Why would any creator pay hundreds of dollars for a clip that sort of fits their vision when they can spend a few cents in ZSky to generate the exact cityscape with the exact neon lighting and camera angle they need on demand?
It obliterates the generic footage market,
Gone.
but because of the audio sync, the collateral damage goes much deeper than just stock video.
Oh, it extends directly to the voiceover and localization industries. If the text-to-speech engine is convincing and the lip sync perfectly matches the phones, the barrier to creating a fully voiced, multi-character explainer video drops to nearly zero.
Yeah.
Previously, an indie developer trying to make a promotional video for their app would have to hire a freelance voice actor on Fiverr,
Wait for them to record it.
buy the stock footage,
Yeah.
and then pay a video editor to stitch the audio and visuals together.
Which takes weeks and thousands of dollars.
Right. Now, that same developer orchestrates the entire production themselves in a single web interface before their lunch break.
We are basically giving Hollywood-level studio capabilities, the cameras, the lighting, the actors, the sound design, to anyone with $7 and an internet connection.
It completely democratizes high-end production value.
But it also rips the floor out from under the working-class creative economy. Like, a lot of people make their living doing this.
We are transitioning from an era where production value was dictated by capital to an era where it is dictated purely by imagination and prompting skill.
That's a huge shift.
The tools to craft complex, fully voiced narratives are no longer locked behind the gates of major studios or massive tech conglomerates. The power center has shifted to the individual.
Which perfectly circles back to the story at the center of this entire deep dive.
It really does.
We set out to analyze how Semhan Berichik, a single solo developer, fundamentally outmaneuvered the most well-resourced technology companies in human history.
And he did it with hardware from a gaming PC.
He took 7 consumer-grade RTX 5090 graphics cards, hardware you can buy off a shelf, and circumvented their physical limitations by building a brilliant 12-model modular routing pipeline.
He built a kitchen of hyper-efficient specialists instead of a massive lumbering oven.
And by doing so, he achieved the industry's white whale. Synchronized video and audio generation integrated into a single prompt delivered in 8 seconds.
It's an incredible achievement.
He undercut the venture-backed giants on price and beat them to market on functionality.
The core realization here for the listener is that the structural advantages of massive corporations, their endless capital, their massive data centers, their thousands of engineers, are no longer guaranteeing them a monopoly on innovation.
Right. Big doesn't mean fast.
Agility, modular software architecture, and a focused vision allow the individual to move at a velocity that a bureaucracy simply cannot match.
It is the ultimate David and Goliath story of the modern tech era.
Truly.
But it leaves us with a fascinating, almost unsettling question to look forward to. And I want to leave you, the listener, with this thought to mull over as you watch this industry evolve.
Yeah, let's hear it.
We have just watched a single developer in his garage beat trillion-dollar tech giants to a fundamental milestone using the coding tools available today.
Right.
But the tools are getting exponentially smarter.
Very quickly.
What happens tomorrow when solo developers stop writing the code themselves and start using advanced AI agents to autonomously code, optimize, and orchestrate even more complex software pipelines?
Now that is a terrifying prospect for the giants.
If one guy can outpace the giants today by being clever with his architecture, will the massive tech conglomerates eventually be completely out-innovated and rendered obsolete by an army of their very own users, armed with AI software engineers?
It's entirely possible.
It's a wild thought, and it means the barrier to entry isn't just shattered, it's practically non-existent.
Exciting times.
We'll leave you with that. Thanks for joining us on this deep dive.